Hello, everybody, and welcome to the speaker session today, which typically are on Thursdays, but this week specifically, we have moved it to Friday, and we're going to have MG Park from ENCODE Club join us today. MG, welcome. Happy to have you on board with us. And the way that the session is going to go is we're going to have MG who is going to give us a presentation, talk about it a little bit. Then I will be moderating, asking a few questions myself to MG. And throughout the whole session, you all are more than welcome to ask questions in the chat that we shall address over time. But first off, let's give her the time to give her presentation, to introduce you to the project, and then we'll go into the questions, okay? So welcome everybody, happy Friday. And looking forward to listening to you, MG. And you are co-host, so you have the capacities of sharing your screen.
Okay, thank you. Thank you very much. Happy Friday, everyone. Good morning, good afternoon, good evening, depending on where you're located. Let me share my screen, 1 second. Now, everyone, can you see my slide?
Yes, perfect.
Okay, that's lovely. Hello, everyone. Thank you for inviting me to Unit Master. I'm really happy to meet you, and I'm really happy that you're being patient with me. I'm Amji, Head of Research at ENCODE Club. Today, I'm going to share a little bit story about the consensus at blockchain. Before that, let me quickly introduce what I'm doing. I'm from ENCODE Club. ENCODE Club is a Web3 education community like Unit Network. We train talents through programs like bootcamp, hackathon, accelerators, and workshops. So a lot of our programs are more like a dev focus. And then we help the talent get either get a job or get fundings. Our hackathons or accelerators, perhaps you may think that this is only for the developers, but actually you can join us and maybe you find your fellow developers who are going to be your future CTO. So I was having a chat with the Unit Network many times that we can perhaps share some workshops together. So thank you for inviting me again. It's going to be a really great opportunity to share what kind of things you want to know more about blockchain. So today in this session, we will map the history of the blockchain consensus a little bit and explore various protocols together. It may sound a little bit complicated at first, so let's start simple. Today's my goal is not to understand everything in depth, but have a feeling what kind of consensus is. So what is consensus and what kind of consensus existing in the industry? So what is consensus? Consensus itself, the term is like literally a general agreement. So in blockchain, like there's a different types of nodes, and then in the blockchain, they kind of need to agree on a single truth of the transactions. That's the consensus mechanism comes in. To make single truth together in the central system, there's a multiple challenges coming. So we're going to check it together a little bit later. To reach the consensus, majority should agree on the single truth, and how to do it is different per blockchain. Before going into the blockchain completely, let's think about like what kind of consensus do we experience in our life. So we as a human have been making a lot of different agreements together since a long time back. Yes.
I'm just going to stop you quickly. Can you slow down a tiny bit the pace just for the recording and for the audience?
Sounds good. Sounds good. Okay. Thank you.
Thank you.
Okay. So let me recap it in a little bit about it. So they're like a consensus is a general agreement. We can kind of agree on something together as a human together. In blockchain case, it's a node, which is the kind of computer operating the node. So as we human, we have been making different like agreements together. So we can kind of check what kind of agreement we can make it together today. Something like, let's have a lunch together. If you're going to lunch together within like 50 people now in the chat room together, we need to decide the lunch menu. It can be quite a hustle, like checking like all different 50 people, what kind of lunch menu they want to eat. They're going to be different way to decide what to order. Maybe I can ask everybody one by one, or maybe I ask a first 10 people and asking you like, can you grab another 10 people and ask? Maybe it can be overlapped group, it can be not. So these kind of things are a nice analogy of different consensus of different blockchain. And reach the consensus, of course, there's a different challenges coming. What kind of challenges we're gonna face? For example, someone can give me a wrong information. So Falve want to have a maybe like margarita, and then like Harish come to me and saying that actually Falve want to eat, I don't know, Hawaiian pizza. So it can be a false information, or someone can just like misdeliver it, that they didn't maybe tend to give the wrong information, but it can be misdelivered. Or it can get much more complicated in decentralized organization, especially at scale. Now we are 50 people, but if you're 500 or 1,000, it will be much, much more difficult. So how can we come to the valid consensus? To do so, we need to solve few problems. There's a very well-known problem called Byzantine general problem. This is from game theory, which describes the difficulties in decentralized parties to arriving at a certain consensus. Let's jump into the graphic to make it easier. So this game theory analogy behind the like Byzantine genres problem means that there's a kind of, in the Byzantine, there's like 4 different genres. It can be more than 4, of course, genres are there, and they need to attack Byzantine together. The problem is, if they attack all together, they will win. But if they don't attack all together, so if they attack in different time, they will lose. So now the question mark is, they have a problem that they don't have a secure communication channel. So when they're sending messages to each other, it can be intercepted, or it can be deceptively sent by Byzantium defenders. So they need to find a way how to communicate well. This kind of problem comes only at the centralized system, such as blockchain, because if it's a centralized one, we may have a trusted authority, so there's someone going to be organizing and curating the communication, saying that this is right, that is right. But in decentralized manner, and if we don't know our other validators ID, then we come to this problem that, oh, can we trust this party? There comes the model comes Byzantine fault tolerance. It's often called BFT. Again, please, you don't need to remember all the things by heart. You don't need to remember the name neither. My goal today is like you remember BFT kind of somewhere there, that if someone talking about, oh, consensus mechanism or like a BFT, I kind of want you to think that, right, I heard about it and I can read it again. So BFT is to solve this like Byzantine general problem. This is kind of giving a guideline that it says that even though there's maybe one general who are traitors, so they were giving a malicious information, still whole system should be working. So in definition, it's kind of the feature that distributed network is reaching the consensus even when some of the nodes in blockchain case are failed to respond. Maybe like they just couldn't respond simply, or they respond with the wrong information. So this is the kind of basic of the blockchain consensus. And early stage in 1982, there was like Byzantine general problems, like research by Lamport, and then this new model was introduced, and all different consensus mechanism was researched afterwards. So how does this BFT apply to the blockchain? So blockchain is a decentralized network. It doesn't have the coordinator, directors, managers who can enforce the rules or determining or punishing the malicious behavior. So we can have a code or set of the rules which can incentivize, which is often like coming with the tokenomics, right? So incentivize or slashing the malicious behavior, but we don't have a such central party saying that you are right, you are wrong. So how this Byzantine fault tolerance was giving a kind of guideline to the blockchain. So a lot of blockchain consensus is a Byzantine fault tolerant. And in blockchain network, we need to carry out consensus like continuously many different times. And then we need to also want to achieve the scalability. We could solve the Byzantine fault tolerant like a model without a blockchain before when it was a smaller scale. But if you want to reach the consensus in a bigger scale, this model consensus mechanism and then blockchain come together is kind of innovative solution we found in the research. So that's the kind of the starting of blockchain, why it becomes super useful, because we want to reach the consensus between decentralized parties in a scale, then, oh, blockchain is the right solution to use. Okay, so now let's go jump into the typical consensus models perhaps you already heard about. This is like POW. POW is like a proof of work. I guess many of you perhaps heard about it from somewhere at least. Proof of work requires the miners. You heard about maybe Bitcoin mining. So miners, we're going to explain what miner is, but proof of work means that you need to prove that you are using processing powers so that you are contributing to the ecosystem. So let's go back to our lunch menu. So when you're deciding lunch menu, I will give you maybe each of you one page of the quiz so that you can solve the quiz. And everyone is like keep solving the quiz. Maybe someone is not solving either, not contributing to the ecosystem. But if someone solved the quiz and that person has the right to saying that which menu it is. It's a bit oversimplified one, but it's something like that. And here, important thing is this quiz, the content of the quiz is not necessary or like not relate to the content of consensus at all, just is a cryptographic quiz. So solving this quiz is not implying that you have a knowledge of solving issues in blockchain. It's rather like you are just solving the quiz, means that you are contributing your kind of manpower, your computer processing power to the ecosystem. And these keys can be kind of different from blockchain, so that even like same proof of work, different chain can use different consensus model. So Nakamoto consensus is a really well-known one. This is mainly based of the Bitcoin. The reason I wrote all consensus name instead of the protocol name, again, I want you to just like think about, oh, there's a Nakamoto consensus. You don't need to remember all the name because we're going to have a bunch of names today. It's rather, if you heard about it, oh, I heard about that. Okay, that was perhaps proof of work or proof of stake. Now you know what to search because you once saw this name. So this Nakamoto consensus, there's like two different things to remember is like basically proof of work is literally proving your processing power. So your computer is keep running and try to find the answer of the quiz. And this needs the computation power, not the knowledge of certain thing. And then Nakamoto consensus is when you're very, very quick at solving the quiz, each time you're gonna have the right to say if it was a pizza or burger. And then if you have the longest list, so if you solve the problem like the most, you are the one who can have the like a right transactions. So if there's a blockchain is making the each blocks, the longest one is the right one is the basic concept of the Nakamoto consensus. And then another one, proof of work, many people are confused now, perhaps who are quite new to blockchain, is actually Ethereum. Ethereum is proof of work as well, which is moving to proof of stake. So Ethereum is also like Bitcoin using the consensus protocol proof of work, which is going to be phased out, and then they're going to use the proof of stake. The main difference with the Ethereum and Bitcoin is kind of the purpose of the chain. So Bitcoin was made to replace the current like finance system, while Ethereum is more made for interacting with the different apps. So it's more like a platform that people can build the apps and interact on top of the chain. Besides that, of course, Ethash could have a bit of difference than Nakamoto consensus. It's also giving a different types of kits. So you need to kind of find a certain nonce of the block, which again, you don't need to remember the name. And then also they both have a different like a design of the like block time and so on. So for example, in Bitcoin case, if the block time is 10 minutes, it's not the quiz has always same difficulties. They're changing the difficulty of the quiz that people can fit into the people can answer the the quiz on the right timing so that they can keep the same timing all the time. So these are like a main two proof of work blockchain we all know. And then another hot topic is proof of stake. So proof of stake is another common consensus algorithm that involves as a like low cost, low energy. I think you heard about many like green blockchain because they are not using processing power too much, because as we talked about it again, proof of work is using processing power and the quiz itself is actually not really contributing to the knowledge. It's just like a work for work. So to prove that you are committed, they just need to compute each other. So instead of the proof of stake is not like a mining, rather staking. And based on your stake, how much token supply you have a different types of voting rights. And depending on which protocol, of course, this voting right is designed in different way. We're going to look into it a little bit together, how they're reaching their consensus in different protocols. And so before jumping into the different protocols, I would like to emphasize on a few key points of the proof of stake. So first thing is it's using the staked token instead of the computation power. So to join the consensus, you need to have some tokens, not like a computing. It can be pros and cons. For example, in Bitcoin, you don't have any token, but you still can join the consensus trying to mining the things. But of course, it needs a lot of computation power. Perhaps you need a really, really good computer. But then on the other hand, POS, you need a token to join. So if you don't have any token, you cannot join the consensus. But if you once have it, perhaps there's a less barrier to joining. It depends on the protocols. Again, some protocols has a limitation, like you need to have at least 2,000 token, 1,000 token. It can also happen. We're going to look into it shortly. And another point is because of the proof of stake, we don't have a miners there. We have a validators who are validating the transactions by contributing certain protocols, giving a reward to validator, certain protocols not. This is also a matter of design. And then validators are not competing each other. So when we were having this pizza, with the keys, you needed to compete each other who served the keys the first. But in proof of stake case, it's a randomly selected. So when we say that, okay, we are going to have a pizza, which pizza we're going to eat, instead of I give you the keys and someone need to serve, I will say that hey, randomly, you and you and you, can you give me an answer? And then we're going to agree to the certain consensus. Again, this is oversimplified. They will have a different types of the process, but again, this is kind of random selecting processes involved. So let's jump into the little example. Avalanche consensus and Snowman consensus. I want to ask which protocol it would be. I think it's obvious because it has the name of Avalanche. Maybe you heard about the protocol. So Avalanche is another open source platform for launching decentralized finance applications or enterprise blockchain deployments. So this is quite popular recently, especially with all different DeFi games, like DeFi Kingdom was making their subnet on Avalanche. There's a lot of different activities going on. But here today, I wanted to share was how Avalanche consensus is working. So what Avalanche consensus is doing is very interesting concepts. They have a sub-voting. So what happened, no matter what, we have a 2,000 or 20,000 people, Avalanche always has the kind of set of the number of people they're going to ask. So here we have now around 60 people, and to order the pizza, I will pick 5 people randomly and asking which pizza they're going to have. And then everyone said, and not everyone, but the majority said that, we're going to have a margherita. Then what's going to happen? I pick another 5 randomly and ask the question which pizza they want to have. And then if they say margarita again, then this answer become plus 1 point. But if they say that, no, we're going to have, I don't know what pizza could be, carbonara pizza. I don't know if it exists, then it becomes 0. And then I need to ask him questions again. So in Avalanche consensus, you need to set random number of the sampling and asking them the question. If majority say certain answer, it come to the kind of mini consensus, right? And after that, you are keep asking questions to different groups. If it's consecutively having same answer more than certain times, in current Avalanche, I think it's 14 times. In that case, it comes to the conclusion. So it's a consensus. But if it changes, the count becomes 0 again, and you need to have the consecutive things. So even though same proof of stake that Avalanche, also you need to have an Avalanche to join the consensus, in a grand scheme of the concept, how to reach the consensus can be very different. And this concept help them to scale very quick, because regardless how big audience you have, you always have the limited number of the subset you're going to choose. So usually it's a 20 nodes or a 30 nodes, depending on how you design, and you're going to use this consensus mechanism. And then Snowman consensus is basically same thing, but for the linear model. This one, I will not go into the depth, just I wanted to bring both names that you kind of remember that both are related to Avalanche protocol. If you're interested in about Avalanche more, of course, you can read their white paper, or you can also contact me so we can have a chat. To become an Avalanche validator, normally you should have 2,000 Avalanche, so it's not that easy, cheap, I would say, but the innovative model Avalanche consensus has very interesting, so I highly encourage to read some articles about that. Next thing is Nightshade and Doomslag. Does anybody heard about it? Because this doesn't have a really hint which protocol it would be.
MG,
So
I'm just going to stop a little bit here to create a little break and ask a few questions from this first part of your presentation.
Okay, sounds
because
good.
Nightshade and Doomslug is super cool, super interesting, but it gets very deep tech heavy. And I want to really kind of just make sure that the first part has been understood and deep dive into. So I'm just going to go back a little bit to one of the questions that I saw. Sorry, everybody, I'm under the weather today. Can somebody give us a bit, could you basically break down in simpler terms the Nakamoto's consensus?
Okay, so Nakamoto consensus, one thing Nakamoto consensus we can remember about is, so there is a basic concept of the proof of work. You need to keep working and then you need to answer the quiz. If you have the right answer, you have a right to propose like a right transaction. But then the Nakamoto consensus among them, if you're making if you're the quickest one, so if you make the like blocks the longest one, so longest block is the truth. It's a kind of the simple concept we can say about Nakamoto consensus. So like there are going to be like a different type of parties going to be answering the question. And then if you make the longest block, longest chain is the truth, is the Nakamoto consensus in an oversimplified version.
Perfect. Thank you. I'm going to address another question that we had as well. Thank you, MG, for taking the time with us. So one that I think is a really good question, and we talked about it yesterday in the more hands-on chat that we had with the team, and the team is all of you here, is POS, so proof of stake, less secure than proof of work, POW?
I think it's debatable. It really depends on for me, like I cannot really give a clear answer because I think it's quite debatable. So I can try to introduce both parties' opinion. So like a proof of work saying that because you need to use such a processing power, you need to really work on it, right? So that it's kind of preventing malicious behavior, because after all, if you're malicious, you lose all your, how to say, like an opportunity cost, right? You're using your processing power there and you're gonna earn nothing. And then proof of stake, on the other hand, is again, like you put your stake in it, so you cannot actually participate in the vote if you don't put your stake there. And if you behave maliciously, it may get slashed. So it really depending on, it's again, like a very high level concept of the proof of work, and proof of stake is like that. And then within each proof of stake, they have a different way of like securing their security. So I think we cannot simply say that one of them is more secure or not. I think we need to look into individual case and perhaps also individual use cases.
Perfect, thank you. And to continue on the proof of stake question, does proof of stake favor those with more tokens, or is there a way to mitigate over token valuation?
I didn't understand the question.
So the question is, does POS, proof of stake, favor those with more tokens, or how is that mitigated?
Like mitigate like what? I'm sorry,
so
I didn't
for example,
really...
No, it's okay. It's good. This is good. So for example, in proof of stake, sometimes there is mechanism for people who can keep on voting, but have different amounts of tokens staked, or does the proof of stake only favor people with a lot of tokens versus less tokens?
Okay, no. So like it's again, it's depending on the protocol. So there is some protocols who allow you, if you have more tokens, you have a more probability to picked up as a validator. And then there's also other protocols who actually doesn't give you such advantage at all. So this is like another about whole proof of stake. It's again, within the proof of stake, there is certain like consensus allow you to having a benefit if you're having more, how to say, more tokens, and certain things like not. But one thing, common thing I can say is, even though you may not choose as a validator, but often each token is representing one vote. So obviously you have a more votes if you have a more tokens. But again, there's like a many discussion going on that if they can weighing that, how can they like prevent the malicious behavior that then someone gonna be splitting the wallet so that they can have a lot of votes. This is something still in experiment mode, I think. But a simple answer is like they're different, and depending on the protocol, some protocol give advantage, some protocol not.
Fantastic, thank you. I hope this clarifies a little bit more to everybody. And one thing that Jill asked, and I would like to amplify as well, is you talked about answering the key and quiz means. Could you go back around the consensus keys that you were talking about? Because this was a little bit unclear for me as well, and for the audience.
Okay, so it's not, I think it's my pronunciation problem. It's not keys, it's quiz. So you are answering the quiz. And so this quiz means that like such as, just imagine that I give you mathematical, it is actually mathematical quiz you need to solve. So like your computer need to solve very complicated cryptographic quiz given, so that you need to find the answer. And like a Bitcoin and Ethereum have a like each like different style. So they're like in Ethereum case, perhaps like you need to kind of keep putting your answers till find like a nonce. And then like a Bitcoin also you need to solve some problem. So it's a quiz. And this is not the quiz we think that like hey, where is the capital city of Germany? It's more like a kind of mathematic cryptographic quiz. It's like puzzle. Yeah.
Okay, fantastic. Thank you.
Thank you.
Any more questions for the first part of everybody? And if not, I'll let you, MG, continue on the second part, and then I'll have a few more questions for you. So you can go into the second part. Again, I would ask you to really take your time in giving us the explanation, and the floor is yours.
Okay, thank you. So we're gonna now jump into the another consensus. Again, like I think there's a lot of different names gonna come, and this is a very difficult topic. I think each of them needs like a several hours of study. Every of them, like I don't understand completely in depth, like you need to go through different white papers. Sometimes you need to wait updates because even some of them are not well written in white paper yet, unless you met the engineer and asking questions. Here again, let's have some concept, what kind of thing exists and what kind of protocols are using what consensus. So Nightshade and Doomslug, I don't know if you heard about it. This is from Near. So Near is a decentralized development platform using a proof of stake consensus mechanism. And this Nightshade and Doomslug is the they're like a consensus mechanism, which is like contributing to their block finality. And also I'm thinking like perhaps like you may have a question of the finality, but like let me just like finishing this first, and then like block production technique. So in this like blockchain scheme, Doomslug is helping to produce like blocks faster. So before blockchain become the reach to the finality, it kind of finalize its transactions, like saying that okay, it's not we will not, how to say, unroll it anymore. And then Doomslug is meanwhile kind of making a mini finality. Again, this is my word, like oversimplified one. It's saying that okay, let's execute it. It's not like a finale, it didn't reach the finality, but we can kind of make a faster execution by allowing Doomslug, saying that this is considered the right transaction. And then Nightshade is more like a sharding architecture of the blockchain. Maybe you heard about word sharding a lot, but I think sharding itself is very complicated topic. What you can say, very simple version is sharding is kind of splitting the parts, and then you can do the things in parallel in Near case. So that in one block, we have a lot of different block transactions, but in Near, there is a name called chunk. It's again the name of the Near thing, so you don't need to remember all the terms, but then there's a little groups of the transactions and they can be worked on like in parallel. So Nightshade is a kind of coming from their sharding architecture. And then Doomslug is before like finalizing everything, they kind of execute the things and saying that this seems right, this seems right. So this, what I wanted to introduce from this was, again, maybe you realize that they're from same proof of stake, but Avalanche and Near is using very different types of concepts. So this is really interesting if you're seeing, and a certain ecosystem might be more interesting for you. So then you can pick up and perhaps you can study a little bit more. And then next one I want to introduce is Tower BFT and POH. Perhaps someone may know about POH because this was quite popular last time. So this is like a consensus mechanism and then optimization technique from Solana. So Solana is public base layer blockchain protocol that optimizes the scalability. So Solana, perhaps it could be debatable, even though it has a downtime, it is well known as a very, very fast chain with a very minor fee. Tower BFT is a proof of stake consensus algorithm, which is like a BFT stands for Byzantine fault tolerant model again. And then what is this POH is proof of history. Often you might find the article saying the proof of history is consensus of the Solana. If you say very precisely, this is not really for consensus. This is kind of contributing to the faster transaction. So it's an optimization technique itself is not really a consensus one. What proof of history is doing is you can consider this as a cryptographic clock, so that there is a kind of the lead. And the leader is saying, leader kind of knows that like which one happened in which order. So when transactions happen, okay, you first, you second, you third. So the proof of history. So there is a leader who knows the history, that who kind of ordering the transactions in order in time manner. So it's a cryptographic clock. So someone can say that because there is a lead who gonna kind of ordering them, perhaps a little bit less decentralization, but meanwhile, this increased the scalability amazingly because it reduced the overhead. And then next one gonna be Grandpa and Babe. I don't know if someone heard about this. I assume that perhaps this is quite unfamiliar. This is another like consensus related models from Polkadot ecosystem. I am pretty sure that to make it as a Grandpa and Babe, I think they make it unnecessarily difficult name to make a great abbreviation. But anyway, when you go into that, Polkadot ecosystem, if you never heard about, Polkadot is a blockchain network, again, designed to support the various interconnected application. The founder of the Polkadot was actually co-founder of the Ethereum, and then he had a kind of different vision, so he built like a Polkadot out of it. Polkadot has a relay chain, which is kind of base chain, and have a lot of different parachains, which is communicating with this. So relay chain is taking care of the security part, and there's a lot of different parachains focusing on certain functionality or certain like applications. And then in this Grandpa and Babe is quite similar to, I think, like let's say like a Near one. So one is taking care of the blockchain produce. So Babe is taking care of the blockchain production part, block production part. So it's like a contributing onto the production side, and Grandpa is more in the side like taking care of the finality side. An interesting part is what I wanted to actually emphasize on this was Polkadot was not starting from POS before. In early version of Polkadot was starting with a proof of authority. So instead of like proof of stake, they were managed by only 6 validators, which belong to the foundation in the beginning, very early stage. And then they transit to the proof of stake. And now each party who has a stake can contribute or like participate in the consensus. So you can see that blockchain consensus is also a little bit evolving depending on like how they grow. So maybe from the first place, their long-term goal is making a proof of stake, introducing all this like decentralization with the different parties. But in the beginning, just to maintaining things in the beginning, they started with a proof of authority. And those kind of cases, perhaps you're going to see more and more.
Thank you, MG. So just to take it just a little step back here again with what MG just presented to us, all these proof of something, proof of history, proof of stake, proof of work, Grandpa, Babe, all of these are consensus mechanism. And when we talk about consensus mechanism, they're how will the chain be automated to work in a specific way? So how do we make one blockchain, one chain on Polkadot, all of its parachain, this is how Polkadot works, will have, in a way, its software be automated, and therefore the language, the sort of the intelligence of the blockchain in itself. Avalanche will work differently, Near will work differently, Ethereum will work differently. Those are all the consensus of how they work, protocol consensus. But if you look even finer, as MG has been presenting to us greatly, it's very much to the bottom line of each transaction sent on the blockchain, how they are calculated. It's around the security. All of this impacts security and scalability of a blockchain. And they're really important to at least understand to a high level. And if you start coding more into crypto, or you come as a developer a software developer wanting to come and code into crypto, you have to look at those different consensus mechanism, because that is going to be a big part of the blockchain you're going to develop and that you're going to build upon. And MG is part of ENCODE Club, which does Web3 hackathons. And that's something that when you do Web3 hackathons, you look at the technology, you look at the blockchain, and you look at how the teams that are building are taking these consensus mechanism into consideration, into the solutions they offer at the hackathons. So that's why it's super important. It seems like a lot at the moment, but just to have a high level of the different consensus mechanism will be a great deal for you to understand the different projects that you will encounter in crypto and how they work. And it will be dependable of where you come into the Web3 space. Are you a judge for hackathons like I've been doing for quite some time, or are you joining teams to build? So you're going to have to look at consensus mechanism all in all at all times. You don't realize that you look at them and you interact with them, but actually when you're simply talking about staking, you're actually talking about proof of stake. If you're talking about mining and Ethereum being a clogged network and gas fees being super high, you're talking about proof of work. It comes down to the same thing. They're correlated to one another. So with this in mind, I would just like to ask you, MG, like a personal question about the work you do at ENCODE Club. And ENCODE is the Web3 hackathon. And what is it something that you would an advice that you would give the teams when they join a hackathon building in Web3? What are like considerations they should have for building?
Actually, before that, can I introduce just one more, because only one last left, one last left consensus, and it's actually related to the question before. So sure. If it's fine, I will quickly jump. Yeah, this is the last one, everyone, so no worries. So this is a pure proof of stake from Algorand, and the reason I said that this is related to your previous question is one of you was asking about if I have a more stake, if I have a more impact. So in Algorand, the innovative part of the pure proof of stake is they were trying to avoid the rich get richer situation. So they were proposing a little bit more like an egalitarian concept. Even though you have a more tokens, you don't really choose like a more. So there's a probability of being chosen as a validator is not depending on how much you have. Again, still, it's not completely not related to the size of the token you hold, because each token is representing one voting right. So voting itself, still you have a more votes, but chosen as a validator is not getting advantaged by how much you have. So this is the case I wanted to quickly share. So they're like, you know that, oh, my question was actually super valid question, because blockchains are like a kind of competing each other, sharing those concepts, and your question was exactly hitting the spot that people are looking for this, and blockchain is in the end designed by human in certain way, right? So we are looking for certain philosophy, which ecosystem is driving by which vision. So I thought like your question was very, very interesting question. And after this, so let's jump into the answering question of the Fauve. And thank you for like great summary. It's really great that also that's exactly my intention. I want to motivate people here coming to different hackathons, accelerators. If you're working with the developers, I don't want you to understand this like everything super in depth, like reading papers and like a coding, unless you're interested into. Then of course we encourage, but otherwise kind of know in high level helps you to working with the developers, understanding the ecosystem, what kind of vision that ecosystem wants, gonna be eventually helping you if you're applying for their grants application, if you're building certain apps, you're gonna build the apps which fits to the personality of that ecosystem. So I wanted to have a chat in general, what kind of things existing. So I just saw someone asking, are there online hackathons? Can anyone share? So Incode Club is making a lot of different online hackathons. Let me perhaps share the link. So we are making in-person hackathon as well, but majority of our hackathon is actually happening online because it has a great access to everybody globally. So anybody can join. You can go here and you can check, and you can also see some other like a newer information you will see on our Twitter. And then also if you go to our YouTube channel, you can see different like a technical workshops, more in detail for different protocols. Also like there's kind of non-technical workshop, more like an ecosystem overview, but still it's perhaps like we are not really focusing on like business part too much when we are making the workshops, except the fundraising part for the startups. So if you're interested in like a technical workshops, like it'd be quite interesting resource. I can share the link again.
So if you have a good question here as well is about the Unit Master students. Do they have a way to show into the ENCODE programs that they're coming from Unit?
Okay, so if you're applying to our hackathons, especially like online one, we usually have a lot of room to accept. But in person one, there's a limited person can come, normally because of the restriction of the space. In the end of our application form, we always asking them, well, did you know about our program? If you write it as a unit, I will make it sure that unless you apply in really last minute, it is already full. If it's not the case, I will make it sure that you can join and you can meet your CTOs, future CTOs there. And then meanwhile, maybe people formulating questions, if I introduce what kind of projects we are looking for in the hackathon or what kind of projects going to be nice. To be honest, like the last 2 weeks, I think people were a little bit gloomy by all the incidents happening in the blockchain. But I think this is actually a great time to build if you're determined. This is going to be a little bit less noisy. I mean, there's a different types of noise exist, but when you're building something, people are going to be less bothering you. What kind of things you want, you need to build? I think mainly 2 different ways you can think about. One is like, don't try to always solve the problem already Web2 is solving. So perhaps you need to go a little bit wild, and then also try to looking into a different project built in different blockchain. One of the good start is check the Ethereum, check the most successful like apps all there. What kind of things they're achieving, what kind of things are they doing. Maybe in different ecosystem, if it doesn't exist, you may try to build. A great example is naming service. It was quite obvious solution that why people would want to use, unless like, for example, Near has a kind of having already differed like a Near address, like a human readable one, but the others were not supporting, and of course people want, and those kind of thing. Or like oracles. Oracles are kind of backbone of like using if you're building a DeFi protocol, you need to use like oracles to get all the price feeder. Surprisingly, many ecosystems here doesn't have the oracle feeder. Then like this is the kind of infrastructure you want to build, you may look into it. Or another thing is you can kind of check like it's purely curiosity driven. You can be experimenting about, for example, like a GameFi. I would not like a lock myself within the current GameFi model, because all those like play to earn is kind of debatable. I think if it's going to be successful in long term, every game, I think it's really going to be depending on which game is more fun or which game is more successful, not the general case of people who are using that tokenomics going to be successful. So you need to kind of experiment a lot, and that's the thing. We recommend to come to hackathon. Hackathon is usually short periods, maybe maximum like 4 weeks, which is quite long, but still short. You need to pivot your project. So build something which set the like a minimal goal, making a minimal viable prototype, and test and pivot and test and pivot. Don't like make a long shot and making, I don't know, under the stealth mode, building like 6 months and realize that market doesn't want. So I think great opportunity is try to building a smaller model, what you want to achieve, testing them. And if it's working, perhaps you can build like more features on top of it.
That's amazing. Thank you for giving us the building tips. This is super primordial because you want to come to a hackathon and propose the right verticals for building in the different projects. At the same time, something that we're all hearing, and I think some of you have heard or haven't yet heard, we are in a bear market, and us in crypto, when we've been in crypto for some time, there's something to always remember. The bear market is actually the time where people build. It's the time of deployment. It's the time that people put their head down and get working and get researching and all. It's not bad. It's simply part of the market movements and parts of basically making a change into the development and the deployment. So resilience in crypto in bear market.
Yeah, I really agree. Oh, wait. Yeah, I can share my link. Let me. So this is my Twitter, and if you search my name, you can see me in LinkedIn very easily as well. I am really easy trackable person. So you can search me, and yeah, I agree. Like I second 100%, especially if you are working and building something in this like industry, you have a quite limited downside because let's imagine like a worst case happening, like you were working at certain ecosystem and let's say that ecosystem doesn't exist anymore, but most likely you know the like blockchain knowledge, you know how to work with a fast-pacing industry. Either you will get hired by somewhere very quick or you will make another company in different ecosystem. So of course, like if you're saying that, oh, okay, blockchain get it to the moon, so should I collateralize all my house and should I jump in to the DeFi protocol with a leverage position? I would say, no, that's not about it. Even though I am super bullish in Web3, I think investing, you should be very careful what you are doing and you need to know what you are doing. But if you're building something and if you worry about that this industry may shrink like next like several months or a year, then I would say like don't worry too much. I think you're in a good track, and either you make it or not in first ecosystem you're landing in, you will have a great opportunity ahead.
Fantastic. Thank you so much, MG. I don't see any more questions at the moment in the chat. This was a really great full presentation that you've given us. And everybody, there is key takeaway from the session that you can share in the link that was shared just now in the chat. And also be sure to chat about it with each other in the Telegram group. We bounce off ideas. I will always repeat this every week. You will hear me, it's redundant, but we learn by talking with one another, by asking each other questions, by answering them as well. And it's with a community that basically crypto keeps on building. So MG, really happy that you've joined us today. I love the ENCODE hackathons, try to participate in them as much as possible. And this is not the last time we're going to speak. And everybody, please reach out to MG, please reach out to ENCODE hackathon. They're always looking for people with and without a technical background, because we need different people in the teams to be able to build.
Yes,
So
exactly.
On this
100%.
note, I want to, yeah. Do you have any last comment, MG? And if not, I will close the session for today.
No, I don't have specific comment. Just I want to second what you said. 100%. We need every type of people in the industry. Don't hesitate. Also, don't ever think that I'm not enough yet. There are going to be a lot of great opportunity. And thank you for having me again. And looking forward to seeing you, everyone, in somewhere else.
Awesome. Thanks, everybody, and a happy weekend to everybody here.